Okay, guys, welcome to This Week in Investigative Science Honors. We're talking about electricity and magnetism. Go ahead and take out your Cornell notebook, start with this topic, and then put in these learning targets. First thing I want you to do is go ahead and take down these definitions. What we were talking about is going to be involving circuits. So circuits is the electrical pathway that electrons move down, and three concepts that are very important when talking about a circuit is voltage, resistance, and current. Current is going to be measured in amperes, resistance is going to be measured in ohms, and voltage is going to be measured in volts, or capital V. So the best way to talk about a circuit, I think, and the easiest way to understand it is to use an analogy. So we're going to use an analogy of a river and a dam. Voltage in a circuit is the battery, and voltage is really just a difference of potential from one side to another. So here we have a lot of water on this side of the dam, and we don't have any water over here. That's voltage, the difference between this side and that side. So the bigger the difference, the higher the voltage. If this dam were to break all of a sudden, all that water would flow through it. That's basically what a circuit is. The water molecules themselves represent electrons. Electrons are the moving part of a circuit. Current is how fast those electrons are moving through the circuit. So a very low current is like a calm river, right? All these water molecules, or the electrons, aren't moving very fast. There's some movement, but the current is so low. High current is like a rapid river here. We can see that the water molecules, or the electrons, are moving really, really fast. So when we're talking about how dangerous electricity is, it has more to do with the current than it does the voltage. Though the voltage, if you increase voltage, there's a good chance that your current is going to increase as well. And we're going to take a look at different relationships there. Resistance is the things that stop or impede the electrons from moving through a circuit. So low resistance, if we're using a river analogy, is that there's no rocks in the way of this water. It can freely flow and have no issue. If we have a lot of resistance, all these rocks in this river, is going to slow down the flow of our river. It's going to slow down those electrons. And here's a basic drawing of what a circuit would look like. So we have our battery over here that has a certain voltage. We have electrons that move through a wire. That movement is the current. It's going to interact with resistors. Resistors slow down the current, and resistors are also what create whatever the circuit is meant to do. So it might be the light of your phone, or it might be a light bulb, or it might be a speaker of some sort. Those are all resistors. So Ohm's Law is how we quantify the different relationships between voltage, current, and resistance mathematically. Ohm's Law is voltage equals current times resistance. And if we have an increase in current, we have a decrease in resistance, an inverse relationship there. We can rearrange it to be current equals voltage divided by resistance, and we can also rearrange it to be resistance equals voltage divided by current. In these two relationships, we have a direct relationship. So if voltage increases for this equation, so is resistance for a constant current. For a constant resistance in this equation, if voltage increases, so does current. So go ahead and stop there for a second and then come back to these problems.